So welcome again to another wonderful video of mine. As usual, this is Engineer Oyedi, and we are into the last one, which is the last video you expect from me for Waec students. I am only trying to make sure I fulfill my promises with respect to what I told you last year to the glory of God. So I have provided the chemistry. We can see that most of my students did well, and everybody I can see from your comments and messages I'm getting from most of you guys, and the mathematics as well. So now it is time for the physics 2022 Waec exam prep. So this is just what is delaying me for the continuation of my college physics stuff, which I'm almost through with on the other page. And for those who are joining us for the first time, you can consider subscribing to our channel. We have three different channels: the physics channel, the chemistry channel, and the modified channel. So I told you for now, I'm going to be posting all my videos on this modified channel. So if you are yet to subscribe to this channel, you can consider subscribing. That is, if you find anything interesting, and you can tell your friend about the channel as well. So physics 2022 WAEC questions, simulated questions. We are looking into, I think we have 6 questions, theoretical form. So if you still have any other topic you may want to consider checking, go to the physics channel. Here you have our topics for your level and even for those that are above your level. So you just watch what is needed. So let's start, guys. The first question is testing us on Newton's laws of universal gravitation. I believe you might have studied this very well in your thesis. And if you follow my video online too on the physics channel, this has been dealt with to the level of advanced level. So you can consider checking that out if you still have any problem with definition or whatever I want to do here. So we start with the law. You can say it is just the Newton law of universal gravitation states that we talk about the force of attraction, either attraction or repulsion. You can just write it anyhow. I will be short and direct to the point. Between two bodies, between two bodies of masses m1 and m2 is inversely, the force is inversely proportional. It's inversely proportional to the square of their distance. The square of their distance, we like now put apart, and directly proportional to the product of their masses. So that is the way we state the law of the Newton laws of universal gravitation. I know very well most of you've studied this in your classroom, and for those that attended tutorial or home tutoring or whatever, you might have come across these laws that obeys the inverse square law. So without any further delay, we can go to the next question. It is very important for you to actually make sure you use bodies and not substance, because WAEC do actually look into that when we are marking. Because when I do mark WAEC, I do tell you I mark WAEC chemistry and physics. So you need to be very careful when you are giving definition, because there are some important points examiner will look into. So we are not wasting time. We move in sequence to the next question. About the next question, we are to define gravitational field. This is what we are doing now. Students should just follow the line in which I'm using and the method, because it will help them a lot when defining or when doing anything on their physics exam day. So back to what I'm saying and what I'm talking about. A gravitational field is just a region. I permit me to just define here a region or a space. A region or space. Just leave that, in which A gravitational force. Gravitational. A gravitational force is experienced. I think it is not too much to know that all fields, either gravitational fields, electric fields, magnetic field, we talked about them as being a point or a region where force is experienced or felt. Or sometimes you can say the point at which what force is detected, if you are the type that you are used to that. So grammar also matters in definition. A good grammarian will be able to give good definition. But by and large, this is physics. And if you don't even know how to write this in language form, for those of you that know the formula wise, you can easily give answers. I hope you understand that. So in sequence, we go to the B1. The B1 says we have to derive the equation relating the universal gravitational constant. Students should be careful about this. G, universal gravitational constant, and the acceleration of free fall, that is small letter g, which we all know, at the surface of the earth from Newton's laws of universal gravitation, you can say. So we have to get the formula for g, small letter g, from capital letter G. That's what the examiner wants us to do. From our junior classes, to do that, it is very simple to derive this type of formula. Now, to get acceleration due to gravity, we consider the different way. But we have to derive it from Newton's law of universal gravitation. Many of us remember that this is the way we are told that weight is equals to mg, right? And gravitational force acting on what? Force is a vector quantity, is capital letter G M M1 M2. It depends on how you want to write it, over R squared. Some people will write capital M and small m. Does not change anything. So in this case, I am taking this one as small letter m as M1. So it depends on how you want it to be. So if you are the type that you want to use capital letter, it is the same thing. So the amount of force, if the weight acting on the body balances the force, so you can set these two guys equal, and on doing that, you can have M1G is equals to G, or let me make this one M2, GM2G, you have M2G, and balancing them out is equals to GM1 M2 over R squared. On simplification, M2 gets cancelled out, right? So we are having G is equals to GM over R squared. So this is the definition or derivation that Waec actually needs from students. So it's a simple thing, but for these guys to cancel out, there are some certain conditions which you have to keep in mind for you to have this type of situation. So now, the next question says, you have to state two assumptions for which the relationship in these particular questions hold. So the conditions that make this thing to, can say, they say the weight that is responsible, that is pulling the earth, is also equals to the weight of the object that is revolving above what? The orbit or the planet is equals to the force that is responsible for the body to what? To rotate above its axis. So now, my dear students, talking about the conditions that makes this to be equal, for weight to balance out force, there are some certain conditions that you don't even need to think much about. The first one is what? You must think about the earth is not rotating, or the earth is stable. You can write that. Or basically, I can say if the earth is spherical, the rotation of the earth is stable, is uniform, or it is spherical. Another thing I can also bring out here is that Earth is stable or Earth is spherical. There are two different things. If you want to write it in different ways, you can write it like that. But me, I just want to give good points that will make sense for me to balance this. Earth is spherical, Earth is rotating about what? Its direction. Like is the rotation of the Earth is it's spherical. That is why weight can balance force. If you have any issues with this, you can watch the full concept video on this. Now, the other thing is the mass of the object. Mass of the object. The mass of the object is directed inward. If you watch what I'm stating here, it is more like stating the condition of circular motion. That is what I'm trying to state here. So if you write Earth is stable 1, Earth is spherical 2, it is correct. Because if it is not stable, if it is not at equilibrium, you understand, it will not balance out each other. And you will not be able to set these equal. So it's a simple stuff. So we are only to mention 2. I have mentioned 3 indirectly here. Stable is different from being spherical. Note that. And the direction of the mass is what is concentrated inward. The mass is just the acceleration of centripetal force is always inward. I hope you still remember that. So the next one says the C says calculates the force of attraction between a star of mass 2.0 times 10 raised to the power, places 10 raised to the 30 kilogram, and the Earth, assuming that the star is located 1.50 times 10 raised to the power 8 kilometer from the Earth. You have some constant that is given, which you are going to put into your formula. From what we have here, we have the formula for force. So I don't think this one should give us any issue. So simplification, we can say for C1, force equals to G M, the mass of Earth and the mass of the orbit. The orbit here is the star. Write it as ms over r squared. So on simplification, we can just substitute the parameter, and on substitution, we have this is a constant 6.67 times 10 raised to power negative 11. We are multiplying that by the 2 masses. 2 times 10 raised to power 30 multiplied by 1.5 times 10 raised to power 8. You are dividing all your answer by the square of the distance, the separation. Wow. I think I have made a mistake. This is the separation. This is the separation. And this is the mass of the Earth. So that means 6.67 times this. Then this is supposed to be out. Then it will be 5.98, apologies, times 10 raised to the power 24 divided by 1.50 times 10 raised to the power 8 times 10 raised to the power 3. I hope you understand what I've done there. I have only tried to convert that guy here into meters, because everything here are in meters. You can see meters, meters, and meters. So that is that. On simplification, you point your calculator, which I have one here. I'm going to be doing that too. So you can see, I hope you can see. So we have this times that. I don't want to waste my time. Directly, I'm having 63.55. You can also press. I'm having 3.55 times 10 raised to power, this times 10 raised to power 22 Newton as the question answer. So that is the answer to this question. We move to the last one, the last set, which is D. On this particular question, we have to define escape velocity. Escape velocity can be defined, let me put that here, as the minimum amount of energy. Minimum amount of energy. The minimum amount of energy. I say unidirectional energy because it is in one direction. I've explained that on a concept video of satellite motion. You can watch it on the channel of physics channel, mostly academic physics channel. It is there. Now, the minimum amount of energy required for an object, to leave or escape an orbit. Hope you still remember, for before escape velocity can occur, there must be what we call boundness. That is the total sum of energy that is required by the object or the body. The object basically is the total amount of energy, which is always equals to gmm over r, must always be equal to the kinetic energy of the object, that is half mv squared. On simplification, if you do that, you are going to get v is equals to square root of 2gr, which I think it is famous and popular amongst students. So my point is this: definition should not be a problem for you if you are ready for the exam. If you have anything that is related to this, you should be able to understand the concept. And if they ask you to derive it, it is always very easy to derive if you know definition. We said it is when the total energy is equals to zero, or we say the kinetic energy is equals to the what? Potential energy of the body. And the potential energy is also the same thing as the total energy required in a particular orbit under the influence of gravitational force. All these have been discussed under my concept video. If you want to watch, but I don't think that is needed for Waec students. If you're a teacher or an A-level student, you feel you want to actually check it out, you might consider checking it out on the Photocell page. Now, the last question for this part is asking us to state two differences between the free fall G and the universal gravitational G. I don't think this one should also be a problem. We have learned acceleration due to gravity, which everybody knows for free fall. These just two differences, I'll just write them under this top because there is no space. This is a vector quantity. This is Q. And this is a scalar quantity. So scalar quantity. So another one we can talk about, why this vector, that means it changes, it's more like a weight. It's just a differentiate between weight and mass, the mass and the weight of the ball. So we can say this one varies from one place to another difference varies from one place to another, whereby this one is constant. You can also write the SI unit of each of them, for G, everybody knows Newton per kilogram. This is Newton per meter square per kilogram. So Newton per meter per kilogram, whatever. So the SI unit is another thing you can also use. See, Newton Newton meter square per kilogram. So please note that. So you can also use the SI unit, but it is only to have written to vector quantity, scalar quantity, varies from one place to another. It is constant everywhere. Then the SI unit of this is meters per second square. And for this is Newton. You can say answer for it is also available down there. I hope students understand this. So we are going to move to the next slide. Let's do that now. So the second page says we are to explain latent heat and state two factors that affect the rate of evaporation of liquid. So on doing that, I think this is another important question you should expect. So to explain latent heat, we can say the amount of heat or the heat required for a change of phase of a substance without change in temperature. So when heat is absorbed or gained by a substance, the amount of heat that is required by that body or substance to change the state. The state can be the phase. I'm using phase here according to what I've used on my definition on my physics page. The phase can be from solids to liquids, and it can be from liquid to vapor. So the definition we give to each of them. That is latent heat of fusion and latent heat of evaporation. We say vaporization. But in chemistry, you can differentiate between vapor and gas. So the next one says we should state two factors that affect the rate of evaporation. We have also studied this. We have studied this, and under our study, we've talked about different factors that affect rate of evaporation. Under the topic of latent heat, or let's say heat generally, we've talked about this extensively. For those who follow my studio very well, we talk about rate of cooling and rate of heating of a substance and the factor which they depend on. If you remember, when we talk about the rate of conductivity of a substance, and when we talk about all these things, there are a lot of factors. I told you guys to always keep in mind, but it's a simple question. Waec is always not difficult, you know. They are testing your ability and understanding. So a short way to recall that, even in jam prep stuff I did, that is somewhere around February this year, I talked about this. I said always remember the first two factor in your formula is what we call the area, the surface area, or area exposed area, or you write surface area, as is the surface area that will be affected. Then the next one, temperature. You shouldn't forget that. There are two states, temperature. There are other factors like humidity. Humidity, I gave a shortcut, I think wind, humidity, nature of substance, and I said this is WHAT, which is wind, humidity, area, and temperature do affect the rate of evaporation of a liquid substance. The nature of the substance is also another thing, or the nature of the liquid, as the case may be. So I don't think WAEC is difficult for us to pass. To be honest, if you are cool with physics, you shouldn't have any problem going in there, solve the required question after reading the instructions. Instructions are very important. Don't go and do overdo. You understand? You have to be calm down. You have to be calming down. Let me put it like that. So please be careful to make sure you read instructions, attempt the one you know very well. It's not the one. Then if you want to be unique, if you see that majority of people, if you know everything, are actually taking this particular question, you can decide to go for another, provided you know it well and you are sure about what you want to do. The next question says, B says, explain each of the following observations. On a dry day, water in a clay pot is cooler than water in a closed plastic container. Well, we can attribute this to two major things. It depends on the one you want to use. But whenever you are trying to talk about observations, it's basically you think about what we call about the jiggling and the bombardment of molecules. That is just what we come to your mind first. We are talking about something that leads or that is talking about the physical property of matter. Just use your concept of what molecule jiggling of molecule, collision of molecule stores will help you. But what I think the examiner wants here is based on looking at the area where the question is coming out. It is coming from it. So basically, what the examiner wants is what's my knowledge of Kirchhoff law. Don't worry for O-level students if you don't know Kirchhoff law. The popular law you know, I'm not talking about Kirchhoff voltage law now. I'm talking about Kirchhoff law of radiation. But I'm not even going into that in detail because I will try and explain it in terms of evaporation now. That's kinetic theory, talking about the molecules and matter, collision and jingling of a different matter. So I can say the reason why these water in a clay pot is cooler than water in a closed container vessel is that the water in a clay pot do have spores. I can say spores are available, spores. Or let me say, you know what they call pores, not spores. Now say pores. That means there are pores. Pores are available in clay pots, which pores are available in clay pots. I'm trying to write what you say, which during evaporation heat is absorbed. During evaporation, heat is absorbed by the pot. Or you say latent heat is absorbed by the pot. So what I'm trying to say here, my dear student, is that during the process of evaporation, when the liquid tries to escape through the pores, I mean pores, holes inside the clay pot. You understand? So evaporation will occur, or there is water. Because of that, latent heat of fusion will be absorbed, and because of that, it will make the remaining water inside the container to be hot, to be cool, or cooler than those in plastic container. So in plastic container, there are no pores. Please understand what I'm trying to say. So, and that is the major reason, because of evaporation and latent heat. That is why the one inside the clay pot is cooler. You can write language that is stronger than this. Apologies. I'm only trying to make sure I'm not writing too much, and I want to make sure I am managing the space that is providing for me to write. Now, next one says, food gets cooked faster in a pressure cooker than ordinary cooking pot. I think this is also common, because pressure cooker, the pressure is raised. I was talking about atmospheric pressure. The pressure is raised in pressure cooker. The pressure is raised in pressure cooker, and it is lowered. It is lowered in an ordinary cooking pot. In an ordinary cooking pot. So what I'm saying here is that when pressure, everybody knows the effect of pressure, atmospheric pressure. When you boil something on top of the mountain, it's very sweet height. The same thing about pressure and temperature you might have learned from your chemistry knowledge. Also, we do that in physics as well. You all know how we relate pressure and temperature. So what we expect is that so far the pressure is raised, the temperature is also what? You understand what it means. So the pressure is raised, so we expect what? Food to get what? To get cooked first on pressure cooker, because pressure in it is raised. So that is just the correct answer to that. You don't need to waste your time. Then the C says that the C questioner states two effects of heat on a substance. We've talked about this under the concept of introduction to heat and expansivity. So we say when substance is heated, a lot of things change, but the major thing that changes is the change in the phase. Phase, if you like, you say change in state. Change in phase, it is the state. You can also say it causes change in temperature. Please, you have to write everything in full, and abbreviation is not allowed when you are writing board examinations. You should be careful about that. Please be careful not to write abbreviation, because nowadays most of the students are used to writing abbreviations. Now, I am trying to say something. Then you can also write other things like change in dimensions, like dimensions are linear, which is length, superficial area, and change in density, and change in volume, which is also cubical. Remember that. But the major thing that changes when substance is being heated is phase, which is the state, and temperature, which is also very important. So these are the two major ones. You can write any one depending on the description. The examiner is going to mark it. The next one says if a 40 voltage electric heater is used to supply a current of 12 amps for 1400 seconds to a body of mass of 1.5 kg at the melting point. I hope you know latent heat of fusion of the body. The body melts and the temperature rises through 60 degrees Celsius in an extra 72 seconds. So determine the latent heat of fusion of that. We have studied that until now, but the latent heat is equal to, we can see heat is supplied, heat is gain. So by conservation of what? Work to heat. We know according to J. Mayer, you can watch my concept video. But why explain, please? This is enough. Basic concept and formula, using your formula. application of formula numerically to solve physics is important in Waec. And that's why I keep saying it is not difficult. Now, energy is being conserved, it is converted to work. So we can say ML is equals to MC theta. But I don't see the heat here, it's MC theta, but it's done in terms of energy. The energy we have here is in terms of current, dual voltage, and we have time, IVT. So that is the work. So that is the work, this is the heat. So we just need to be careful to understand what we are looking for. In this type of, these are very simple questions. I don't expect anyone of us to miss. So you can try to understand the physical process. This is the voltage, this is the current, this is the time T1, this is the mass, this is the temperature, change the temperature, and this is the time T2. So the physical process is needed to be understood, and if it is understood, excuse me, now you can easily get it. So the latent heat of the body, which is Q here, is converted into IVT. So the current here is the current I is 12 times the voltage is I'm going with this 40 and the time is 1400. Let's point calculator. We are having 12 times, I'm trying to punch calculator, 40 times 1400. I'm having in standard form, please, and answer should be in joules, 6.72 times 10 raised to power 5 joules. So is the answer to this. And the second one says the specific heat capacity of, now the amount of heat to change what the body from solid to liquid without changing temperature is the same thing as IVT. So that is what I use here. Then after this happen, there is a change in temperature. The amount of heat required when there is a change in temperature is called specific heat. So you can also use the same conservation of energy of heat to work, or energy to heat, or work to heat, which we use in the first one. But in this case, we are going to say the MC theta is equals to IVT. But this time around, the time is now T2. I can take this one the first time as T1, so that we don't have issues when distributing. So on simplification, I can make C subject, and it will be IVT2 over N change in theta. This is always better to write as change in theta so that you don't have any issues. Let's substitute the parameter and have it. What is the current? The current here is 12. The voltage is 40. The time now is 72. I am dividing that by the mass is 1.5. The change in temperature is 40. I hope students get what I have done. I hope you understand this. Excuse me. I hope you understand what I have substituted. So now on doing that, we can now do that directly and get the answer to the question by punching calculator. Oh, change temperature is 60, not 40. Apologies. I will have screwed that 60. So this is it, 60. So punching calculator, you have the final answer. And if you do this well, let's do that together again. This is the calculator. We have 12, 60 times 1.5 is 90. 12 times 40 times 72 divided by 90. I'm having 384 as the right answer. 384 joules per kilogram per degree Celsius. I also know that it is important you put the values of this in your answer. Please don't make a mistake of not putting SI unit in your answer And this is for the second question. So you can see that chemistry and physics are interrelated in some topics. If you are good in physics, you should be good in chemistry if you actually listen to your teacher in your classroom. So in sequence, we'll move to the next question. So the third one, we are taking it down, almost there. I think it is 5 according to the team. So we are to define atomic spectra. I think these are on your modern physics. I have explanatory video for the JAM student on modern physics, which then can also try and watch. But I think this is okay too. The atomic spectra, we can say it is just the emission of light. Let me just define emission of light when an electron, the emission of light when an electron exits or electron move, when an electron move from higher to lower energy level. Or basically, you can say it's just a process because you have to define in a full way. So it's just a process whereby light, the electron emits light when they fall back from their excited state to their ground state. Basically, that is just acceptable. We don't need to talk too much. The next says you should differentiate between emission spectra and absorption spectra. On this, you can draw a tabular form if you want, but without wasting time, we can say the emission spectra, excuse me, emission spectra and absorption spectra. It's just the emission spectra from the definition I gave here is the pattern of light or the pattern of light. I say it is a pattern of light formed when electron transits from higher to lower energy. That is for the emission spectra. Then I can say absorption spectra. Let me use a red for that. Let me just use a blue. Absorption spectra, absorption spectra, you can use a tabular place, is the light pattern form or is a pattern, light pattern, when the wavelength changes. So absorption is basically wavelength, the pattern of wavelength or the change in wavelength during this process. That we call absorption spectra. The pattern formed by wavelength when gas is absorbed. We can write it in full. Absorption spectra is the light pattern formed when the wavelength changes in gases. So I think that is good. I use definition to differentiate. That is what I have used here. So the next one I think is the numerical one. We have what we call energy levels. I hope you have studied that as well. The diagram illustrates an electron transition from n is equals to 3 to n equals to 1. Well, we have n equals to 4 here. I don't know why it's n equals to 3. Then the question here is calculate the energy in the photon. So we said the pattern of what? This is Bohr hypothesis of energy level, and it's only for hydrogenic atom. You understand what I mean? But leave that for now because it is not asked in the question. So basically, we are to just use the video formula. You have also might have studied. So application of the formula is what we want to do here. We know that the energy is the first one. I'll do roman figure 1. We'll do them in sequence. Energy is changing here. You can say that E is equals to change in energy level. You can say change in E1, lower energy level, minus higher energy level. So that's I'm going to do. So I'm following the the energy of the photon. I'm doing Roman figure 1 first. This is what I'm doing, guys, first. So what I'm trying to do now is that you can see this, it is falling from 3 to 1. So lower, this is the lower to 1. We say E3 minus E1, basically, so that we don't have issues. So it will be negative 1.51 minus negative 13.6. Punching your calculator should give you, so I'm doing that. I'm supposed to, that is like saying negative 1.51 plus, as minus times minus is plus. I hope you understand. Don't make mistake because my calculator here is I have 12.09 electron volts. Now, answer should be in joules and not electron volts. I hope you know that. So if answer should be in joule, so you know that to convert energy in joules will now be 1.6 times 10 to the power minus 19. Millikan experiment, chemistry, that is charge of an electron. We have times 12.0 now. So this is what you do to get the first answer. I have to manage space here. Times 1.6. So I have 19.34 or 1.9344 times 10 to the power negative 18 joules. That is the answer I am having for the first question. I hope you understand it, and that is that. The next one is the frequency. About frequency, we can also go in sequence with the energy to get the frequency. With the formula we have also studied, E is equals to HF. I hope you remember this. So therefore, just to manage space, the frequency as the subject of the formula equals to the energy, that is the change in energy I have calculated, over H, which is Planck constant. Please, even if it is not given, you have to know it where it should be given. So apologies, I am not writing it here. Change in energy is 1.9344 times 10 raised to the power negative 18 divided by, this is a constant, I think 6.6, that's what we use in physics, or 6.634 times 10 raised to the power negative 34. So on simplification, you get the frequency in hertz. I'm going to do that divided by 6.6. This is giving me 2.93. This by this. Then this will be plus times 10 raised to the power 18 plus 15. It's 18 plus 15. Yes, I've shifted this by 1. 15 hertz. So punch your calculator. This is calculator work everybody can do. So that's the second one. The third one says wavelength of the photon base. Wavelength we can calculate from V equals to F lambda. V under photon is written as CF lambda, which is that. So on simplification as well, we can just try, because of time, guys. That's why I have to be on the fastest possible approach now. Now C is V. So you can say lambda is equals to C over F. So direct substitution, this is my F answer. C is constant speed of light. 3 times 10 to the power 8. I am dividing the answer by 2.93 times 10 to the power 15. On simplification, I should have, this is 1.02 times 10 to the power 7 meter. So that is the answer for all the calculations we have there. So this is a very simple question I expect you to pick, because it is very simple and very direct. So the next one says that we have to differentiate between the soft S-ray and the hard S-ray. Now, differentiating between soft S-ray, I've done that also on the JAM preparatory class. So these are just repetition. Physics is very simple for basic level. Now, to differentiate between soft S-ray, I told you soft S-ray, they have low energy, low penetrating power. You can just write as many as you want to write. Low penetrating power. But they have high wavelength. Please note that it's about 10 raised to power. They have about 10 Armstrong. I said 10 Armstrong. Between 10 to 100, they are between 10 to 100 Armstrong. Whereby the hard S-ray is just between 1 to 10 angstrom. Note that if they are there, X-ray are produced by heating or bombardment of what? Of light, of atom, bombardment of atom, or the surface of an atom with a target material. So which is always a Coolidge tube or Coolidge whatever we use. I've done that for derivation and application. I don't want to go into that because basic level are very simple. Nothing more serious to be talked about. Just application of formula and understanding some concepts. You are going to get your A's. Now the next one is time is not on my side. You have to draw a circle symbol for a. Hope you understand what I've done here. If you have written this or this, the opposite will be what you are going to write out for the add X-rays. So you need to be careful about that. Draw the circuit symbol for a PN junction diode. Oh, wow. So to draw that, you can just draw a straight line. PN junction diode is simple. On top of that straight line, you can decide to draw maybe a triangle. That is, no, I can draw a triangle. Like this. And there's a diode. You guys have seen the symbol of diode before. And you draw a line back to it. Then you can place the line. Let me use my pen here in front. Here. Hey, wow. It's not straight. That's why I said wow. So this is a junction diode. If you like, you can put a circle around it. If you don't put a circle around it, it's not the end of the world. It should be a mark. So anyhow you are doing it, that is how we draw a junction diode. So that's a PN junction diode, positive and negative. So that's the symbol. Then give reasons for doping semiconductor. Doping of semiconductor is addition of impurities. So we dope in order to increase. One is to increase conductivity. The conductivity. And the second reason is to decrease. If you increase conductivity, you have decreased what? Resistivity. So that is all about this. Like I said, it's a very simple question. You can also, without anybody intervening or helping you to or giving you anything, believe in yourself. You can always do better. You are the best. So the next is going to be in the next page. Let's see. The next page. Well, now, next week. Now, about the next week, we have a question on mechanics. You cannot do away with it. If you are the one that will love mechanics, you fancy mechanics, definitely you should be able to do this. What we've been doing before, atomic physics, we did one on, what's it called, on field, on gravitational fields and stuff like that. We did on atomic physics just now. We did another one on, I think we've done 3 questions so far. We did another one on this is on eats, understand? Now it is on mechanics. Let's see how to answer question on mechanics before the last question. The mechanics question say we should define force and state its SI units. I hope every student can actually define force. Force is what pushes, or is it so most people will say force is push or pull. Well, not bad, but I don't think you are going to have a full mark. So we can say force, it's what is responsible for anything or any push or pull. So I want to write good definition. That is responsible. That is responsible for a change. For a change in state of rest or uniform motion. So you can also say force is that thing that's what? That changes the state of rest or uniform motion to straight line. So they say, and state its SI unit. You know, it's a 2-in-1 question. The SI unit of force is, right, that everybody knows. That should be Newton, if we are not mistaken. Fine. Now, list 2 types of solid friction. There are 2 types of friction, or 2 classification of friction. I told you under friction concepts, solid and what? Wet friction, dry friction and what? Wet friction. So solid friction, which is the friction you are taught in junior classes, is classified into 2. You have static friction, or some people call it limiting, and we have kinetic friction. Some people call it dynamic. So anyhow, time is not on my side, and that is why I am taking it in this way. The next question is we have a question on B part, which is the last one here. A car traveling at constant speed of 30 meters per second for 20 seconds was suddenly decelerated when the driver sighted a port O. It took the driver 6 seconds to get to the port O with a reduced speed of 18 meters per second. Wow. He maintained the steady speed for another 10 seconds to cross the port O. The brakes were then applied and the car came to rest 5 seconds late. We had to draw the velocity time graph. We had to calculate the deceleration during the last 5 seconds of the journey, and we had to calculate the total distance covered. Let us do that together. This is question on mechanics. We should be able to interpret that together. Now let's do that without wasting time. When you want to draw velocity time graph, I know your teacher has told you that you have to put units under the dimension. It's very important. So let me just, wow, that should have been a bar diagram. If I have gone with that, well, thank God I have a cleaner. So I'm going to draw a velocity time graph here. It's going to take on my paper today. Then just hope it is okay. So I'm drawing a velocity time graph in which velocity will be in meters per seconds, and time will be, SI unit is important, I said that, and the time is in seconds. This is the time t in seconds. We can quickly look into it. How do we go on it? We can say a car traveling at a constant speed for 30. So constant speed means the car is moving at 30. Hope anything is not more than 30 again there. Okay, fine. So I can raise my hand up. 30. Let it be too wide. 30 meters per second was there constantly for 20 seconds. That is, this guy was maintained for 20 seconds. I'm going to use a broken line to show 20 seconds. I'm starting from origin of 0, and this guy is 20 seconds according to the question. So, was suddenly decelerated when the driver sighted it. So that means here now it's now coming down after sighting a port O. It took the driver 6 seconds to get to the pole with a reduced speed of 18. So that means the speed is reduced. The speed is reduced to 18. You know what it means. After deceleration, I have to decelerate this guy to a point of not use one, a point of 18, and this was done in 6 seconds. So 20 plus 6, just like your old guy's buff, that's 26. So I'm going to write 26 here. Then I'm going to put this point, broken line, very important. Decelerating with, I don't think it is hard to draw, to 18, from 30 to 18. Okay, fine. So this guy is 18 meters per second. So you maintain the steady speed for another 10 seconds. Wow, that's 26 plus 10, now is 36. We continue with our routine for another 10 seconds. So broken line, interchange. Fine. Then for 10 seconds, so go to 10 seconds, that's 10 plus 26 is 36. Then what now happen to cross the port O? Okay, fine. Then the brakes then apply to come to rest in the last 5 seconds, 36 plus 5. Then it's coming to rest. Now, the no. So in the last 5 seconds, and that is 36 plus 5 are 41. And that is the velocity time graph. And that is what the examiner wants for you. You can label it for full marks, but it doesn't actually mean. So please note that. Then calculate the deceleration during the last 5 seconds. Wow. Deceleration is negative acceleration, or we call retardation. So in the last 5 seconds, acceleration, which is deceleration, negative deceleration is change in velocity over time. It will be u minus v as v is greater than u. You can see this is the retardation part, 36 minus 41. The time it took that to occur was 5, if I'm not mistaken. We have 36 minus 40. Oh, velocity, wow. I would have screwed that. The velocity is 0 minus 18 over, that's negative 18 over 5 meters per second. We can write it 5 times 3 is 15. So 3 is 15, 3.6 ms minus 2. So that's the answer to that. The last one says we should calculate the total distance covered. To calculate the total distance covered, we just have to look for the area under the curve. Area under this curve is what is the total distance covered. So we can decide to go for area under this curve. For area under the curve is just what we are going to do here. Area under this curve. And see the curve. I'm trying to show you the curves. So this is the region of it. So area of the shaded portion is what you can just write. So total distance traveled, just write total distance is all equals to the area under the velocity time graph. So doing that, you now start. The first diagram, apologies, is a rectangle, length times breadth. You can see what we're talking about. This is a 30 and 20. So you just have to be careful when you are doing that. That's rectangle, rectangle. If you want to write rectangle plus the second one is triangle. The third one is rectangle. And another triangle. Sorry, I have to manage space. So now I just have to substitute. So now it started with this 30, and that was maintained for 20. So be careful about that. The 0 to 30, you can see it can be from everything here. Anyhow you are doing it, be careful about these guys, because you need to follow the curve. If I go by length times breadth here, to be 30 times 20 plus area of triangle is half base times height. The base height. The height is from here to here. This was maintained in the base is the distance from here to here. This is 6 times the height is 30 minus 18. 30 minus 18 is 12 plus next rectangle is 18 10 times breadth times 10. 36 minus 26 are 10. And the last one is half base times height. I'm managing. Base of this guy is 5. Height is 18. 5 times 18. On simplification, you can just add 600 plus 36 plus 180 plus 2 times 9 is 45. 945. So adding this should give you the total area of the total distance covered. And doing that should be 636 plus 180. Wow, calculator expression rubbish. Plus 45. I'm saying 861 here. So please, that should be the total distance traveled by this stuff. So I hope you understand this. It's a very simple question. You can also pick tomorrow if you are writing physics tomorrow, it's one of the most important questions you can expect. Velocity time graph, it's very easy when you know how to draw the velocity time graph, even if it's acceleration time graph. Apply the formula of linear motion, which you have studied, then solve them according to the language of the examiner. So the next one will be the last one I'm going to do for this preparatory class, will be question number 5. Let's see question number 5. Question number 5 is not loading. Like I said, this is not moving. This is, I don't know, maybe it is hanging. Let's just hold on. So I hope we understand this, and hope we didn't make any mistake in our calculation. This, I'm taking area of this, and area of this rectangle, area of this guy is not rectangle, this guy is not triangle, this guy is trapezium. Wow. I would have screwed that. Unlike me, this is trapezium. Taking area under the shape. So please, we need to be careful. This guy is trapezium, so it should be, this is trapezium. Trapezium. So it should be half A plus BH. A plus B. A plus B times height. Wow. Thank God for that same hanging. It should have been A plus BH. Now this is 600. This is not 36 again. So we are canceling this. Let's do that one here. Let's do our half this diagram here. This guy is a trapezium. How you can see the trapezium? You can bend the way I'm bending. Because of my camera, it should be upside down. You understand reflection law. So it should be, look at the trapezium like this, like this. This is it. Like this, like this, like this. So, you know, A, B, and H. So that you don't tell us you didn't get A and B. So this is 20 and 18. You can see them now. So 20 plus 18. And the height is 6. This is the height, 20 minus 26. So 2 here 1, 2 here 3. So we have 20 plus 18 is 38. 38 times 3. Where is my calculator? Okay, fine. 38 times 3. 114. So this guy is 114 here. So let's now add 600 plus 114. I think plus 180 plus 45. So 939. So that should be the correct answer, please. So please be careful about diagrams sometimes. This is 939 meter is the correct answer, please. Don't let us go and make silly mistake when we are dealing with our questions tomorrow. So avoid silly errors, look into it again because nobody is above error. To avoid errors, if you are true, you have to just look into it one more time. So let's see if this is moving now. Question number, wow. Question number 5. Follow this. Okay. So the last question we are doing for today. Let's see the last question. So apology guys, it is a pen. And is my writing pen is having issues. So I think it's back now. Now we have a diagram. The diagram above illustrates the structure of a typical photocell. Fine. Identify the parts labeled A and B. Where's A? Where is B? Oh wow. So I hope we know a photocell and how it works. And if you don't know, you can just leave this question. For those that actually know photocell, this is a very simple question and it's very simple to label. So here, a photocell, A here is the side in which this is the surface. So we call the surface here, A is called the emitter. Emitter, and point B is called the collector. Some people will call emitter cathode and collector is called anode. So note that emitter, some people will call it cathode, and this is called the anode. I don't want to waste our time. The last question, time is not on my side. I'm giving 1 hour, 10 minutes, but I'm not sure I've not spent more than that. I'm to state 1 hour, 15 minutes rather. State one function each of A and B. like I've said, if you have written cathode and anode, fine. You understand? So you can now write on the function, this emit electrons, this what collect electrons. Write it in language form. So you can just say A emits electrons and B accept electrons. I hope you understand that. So I have answered this and this. Let's see this one. Einstein's photoelectric equation can be written as energy of photon is HF minus the work function. Say what each of the times EHF and O. Oh, wow. I think we've talked about this is energy of photon, and HF is the frequency of photon. HF and W naught is the work function. Work function. So be careful about that. HF is the combination of the Planck constant and the frequency. So you can write it. We say kinetic energy. E is the kinetic energy of photon. Let me write it like that because it's important. And HF is energy of photon. Because those are some technical things. This is HF. This is E. And this is W naught, as you can see, very close to it. Then the next question says we should calculate now, I guess. A photon is incident. Let me make a rule because of time. A photon is incident on a metal whose work function is 1.32 electron volt. An electron is emitted from the surface with maximum kinetic energy of 1.97 electron volt. What happened? You have to calculate the frequency of the photon. I think this is directly from the formula that is given. Energy, wow, I have to change. Energy, wow. Sorry. We know that kinetic energy equals to the real energy minus the work function. So if you like, you can make X of your formula from your mathematics. I hope students here can make X of formula here. And when this one comes, it will be E plus W naught over H. Everybody should be able to do this. So if you can do that, you just substitute the parameter. Let's substitute. I think it's basically on substitution. Work function is given, I guess. Work function is 1.3 electron volts. We convert them to energy. Then, which other thing? Kinetic energy is E is given. So I'll just do this as 1.97 times 1.6 times 10 to the minus 19. I've converted that to joule. I will also add it. Please, I'm writing on a straight line. Work function is given as 1.32 times 1.6 times 10 to the negative 19. I will divide my answer with the Planck constant. I told you about that. You should know that by that. 6.634 times 10 to the negative 34. So on simplification, my dear students, I'm going to have apologies, 7.97 times 10 raised to the power 14 Hz. SI units are important for full mass. Please note that. Then the last set of questions, but no, define half-life of a substance. Maybe I should define that as using a black. The time taken for half of a radioactive nuclide to disintegrate or to decay or disintegrate. Anyhow you want to do that. So the next one says you should sketch the graph of n equals to n naught. This is it. That is the decay equation. It's available on my channel. N naught e raised by negative lambda t, where lambda is for activity. So if we do that, it's a straight line because You are not given any value and indicate its half-life. That is the half midpoint of it. So half-life is when the time is half of it. So when t equals to t over 2, number of elements is also n naught over 2. Take natural log of both sides, you get the formula 0.693 over the k cos. It is not asked, so you don't need to waste your time. But just to plot a graph, plotting the graph will not be a problem for you guys. So do that, and apologies, I should have used a direct graph something. And if you have that, so we can just draw. Oh, don't mind my hand is not straight. I want to draw a kind of decreasing graph that is coming like that. So this is the time in seconds. This is the number of elements. At half-life, they say you should indicate that is the midpoint of this. You can use a proton line. It's not compulsory to let the examiner know that at this point, the particle has disintegrated to half of its life. And the time here will be t by 2. Then this guy will be n by 2. So this indicates the point of the half-life. So that is that about your physics preparatory class. Apologies, I'm a little bit rushing at the end of the video and some delay due to the lagging of some stuff. So guys, this is it. Prepare well. Questions on waves are also coming, no doubt about that. You can watch that on the full concept video. But these are hot cake questions, I can tell you. You study with this, you are definitely going to get that A you are looking for. So guys, I'll stop here for now. I'll see you soon. If you find anything interesting on our channel, you can consider subscribing. We have other channels too. But for now, this is where we're posting. And this is the channel I want you guys all to invite your friends to. See you guys soon in my future video. Bye and remain blessed.